what I want to talk about today is what emergence is as a phenomena, as a property that's actually essential to understand the nature of the universe we live in, and that's actually essential to understand what it means to be human, and that is essential for understanding the basis for meaning, for ethics, for existentialism, and then also what that portends for the future of civilization and addressing some of the things that are concerning and that are exciting. Okay, so you can consider the next 20 minutes or however long this is as kind of an extemporaneous rambling ode to emergence itself, right? A kind of love talk about how cool it is that universe actually has this property and that we can understand it and participate with it. So let's start by defining what is emergence. Emergence means something new arises that wasn't here before, right? We all kind of have that sense intuitively. But scientifically, how the fuck does that happen? How do you bring particles or planets or anything together and all of a sudden the whole has some properties that none of the parts had? Like, where do they come from? Which is why in the fields of science that study emergence, which evolutionary theory and biology and system science and complexity theory study it, it's considered the closest thing to magic that's actually a scientifically kind of admissible term, but it's still sketchy, right, in terms of the really understanding how this thing works. And because how do we get fundamentally new things out of relationships of things where that didn't exist before? Right? This is fascinating. How do you have a cell that respirates made up of molecules, none of whom respirate? And so it's just really interesting when you actually think about this, right? We have a paired term. Does anyone know what the term is that is key in understanding synergy? And emergence is synergy. Synergy and emergence are two sides of the same phenomena. Synergy means whole that's greater than the sum of its parts. Emergence is what is that greater? It is what is the new stuff that emerges out of bringing things together. And so synergy is more formally defined as properties of whole systems that aren't found in any of the parts taken separately, which also means that are fundamentally unpredicted by the parts taken separately, which portends a future that is fundamentally, ontologically unpredictable from the current state of the future, which is very different than a mechanistic clock unfolding Newtonian understanding of the future, and yet still actually makes sense in terms of scientific law. Super interesting, right? So synergy is this property of relationship where the whole has new properties that the parts didn't have. So emergence is a result of synergy. Synergy is a result of relationship. Does that make sense? And relationship is a result of attractive forces. There are some kinds of attractive forces, whether it's gravity bringing dust together into planets or planets together into solar systems, whether it's electromagnetism bringing subatomic particles together into atoms, or the strong force bringing quarks together into protons. Each of those are emergent properties driven by synergy, driven by relationship, driven by attraction, or whether it's bringing these people together via pheromones or love or intellectual affinity or a topic that we're all interested in, like creating a better world. There's some attractive forces. And so Bucky Fuller called love metaphysical gravity. In the same way that gravity and physical forces act on physical bodies to attract them, we have metaphysical forces that act on metaphysical bodies to drive attraction. But imagine if you think about all of the attractive forces as expressions of a fundamental principle of universe of allurement, that there is a principle by which separate things have reason to come together that offers advantage that being separate doesn't have. And you think about all of the forces as special case applications of that. Imagine if that wasn't the case. Imagine if we had a universe where allurement wasn't a fundamental principle of it, and the whole thing would have stopped at quantum foam, right? You have quantum foam emerge, you don't even quite get to the point of subatomic particle, and that's it, because nothing attracts to then have synergy and emergent properties. I have a friend and collaborator, Mark Gaffney, who calls this universe a love story. Why at the heart of the evolutionary story is this love story, which is that it's actually attraction driving the whole fucking evolutionary story, right? Attraction driving relationship, driving synergy, driving new emergent properties, driving net novelty and new creation, and the arrow of evolution. So we can actually understand the arrow of evolution itself in terms of this set of phenomena together. Does that make sense? So then evolution in complexity theory is defined most generally in terms of more elegantly ordered complexity. That's actually the best definition we have in terms of mathematical complexity theory coming out of Santa Fe Institute. The definition has the word elegance built right in it, because it's, again, one of these actually fairly mysterious properties, but that's key to it, which is bringing things together doesn't give you emergent properties. Bringing them together in a particularly elegantly ordered way does. So think about all the parts that make up a cell, right? You've got all these non-living parts, DNA and cell nucleus structures and all the different organelles and cytoplasm, and they're all not living. And then the cell is living. But if you brought all those parts together but you didn't arrange them as a cell, it was just a bunch of molecules, it wouldn't be that interesting, right? It'd just be goo. If you took the 50 trillion cells that made you and you didn't arrange them exactly this way and you just had like 150 pounds worth of cells, it would be much less interesting. Even though there'd be just as much complexity, you wouldn't have an order in the complexity where the emergent property comes. That's actually the relationship. It's not just heaps coming together. It's not just complexity, it's wholes. And the difference between a whole and a heap is order, and a specific set of patterns of order. This means not every relationship is synergistic. Some relationships are entropic. They actually create the opposite direction of new emergent properties. They destroy some properties that were already there, right? Almost everyone has some examples. But you can bring chemicals together that, rather than self-organizing to create higher ordered molecules with new thermodynamic properties, they have an exothermic entropic reaction and they drop to lower levels of organization, right? This is true at all levels. So it's not just relationship, it's specific kinds of relationship that maximize synergy. This is a key thing to understand about the nature of the universe. It's also the case that if you bring the same thing together, a bunch of the same thing, you don't get very interesting synergies. You get very interesting synergies when you bring different things with different properties together in the right format, where then you have the properties of each of those things and then the properties of the relationship between those, which is the new stuff, and you get emergent. So you've got hydrogen and you've got oxygen, which are different things, and you bring them together and you get water in the basis for life, but neither hydrogen nor oxygen at room temperature are liquids, right? And so this is a fascinating thing. So we're actually very interested in having deep synergistic relationships with differences that lead to fundamentally new emerging properties. So it's not just net complexity, it's ordered complexity, and it's elegantly ordered complexity. And then when you get a new property, then universe selects for that, right? That new property offers some evolutionary advantage to that system that a system that didn't have that wouldn't have. So things can come together all kinds of ways, but the ones that come together most synergistically offer and confer the most advantage, and universe selects for it. So universe is actually selecting for more differences, right? So it's selecting for diversity, and then more synergistic combinations across those differences, and it's both of those, more diversity and more unification across the diversity, right? More agency and more symbiosis at the same time is what defines the arrow of evolution. Does that make sense? Things that are separate, autonomous agents, right? So like a cell, you can think of as having its own agency, right? Its own ability to act and its own boundary and periphery. But you bring a bunch of cells together, and this collection of cells can reflect on consciousness and existentialism and have a conversation like this, even though none of those cells on their own do that, right? And it's different kinds of cells. You couldn't do that with just neurons. It takes neurons and glial cells and immune cells and stem cells, etc., to all come together. So more agency, more differentiation, more orderly relationship, more synergy, all of that comes together, and the net defining thing is emergence. How much fundamental new advantage arises, and that's what evolution selects for.